Two bodies are in thermal equilibrium. Which of the following quantity must be the same for them? A. Internal energy, B. Potential energy, C. Temperature, and D. Mass. Now, from the first information given by the questions, two bodies are in thermal equilibrium. We know that these two bodies must be in thermal contact. But what is the meaning of thermal contact? Let's consider object A and the B. We say that object A and object B are in thermal contact. It means that between them there is a heat exchange. A will transfer heat to the B, B will transfer heat to the A. Now the quantity of the heat transfer between one another can be different. Let's say bodies A transfer 5 joules to the B and the B transfer 3 joules to the A. Now because of the quantity quantity of the heat exchange between them is not the same, the consequences is that the temperatures of this body A and B would be changed as a result of the heat exchange. Now, if A transfer in every second, let's say 5 joule to the B, and B in every second 3 joule to the A, so that means A will lose the heat in every 1 second, and the B will gain heat in every 1 second. So the temperatures of the A would drop, and the temperature of B would increase. So in the end, due to the thermal contact and due to the heat exchange, temperature change, in the end, these two bodies, their temperature would be the same. Now, when they are the same, we say that they are in the thermal equilibrium. So that means the concept of the thermal equilibrium, two bodies are in thermal equilibrium. This concept of thermal equilibrium is closely related to the heat exchange and the temperature. So these three concepts, we can their interrelationship, we can show it in the diagram. This one. Now, two bodies are in thermal equilibrium means that there's no net heat transfer between them. Please pay attention to the words of net. Even though they are in the thermal equilibrium, two bodies are thermal equilibrium, they are still have the heat transfer happens between them, but the net heat transfer is zero. So let's say for A, transfer 5 joule in every second to B, and B transfer also 5 joule to the A. So the heat still exchange, but the net heat transfer is equal to 0. Okay, so if this happens, that means this object must be in the thermal equilibrium. So you can see that in this diagram, the arrows that I draw are all two-head arrows. That means the implications is two ways. When we say two objects are in thermal equilibrium, it implies that between them there is no heat transfer. So if you know that between two bodies they have no heat transfer between them, net heat transfer, sorry, they have no heat transfer between them, that means these two objects must be in thermal equilibrium. So if there is no net heat transfer between them, so it won't cause any temperature change for these two objects. So their temperature change must be the same. Finally, initially they can have the different temperature, and due to the heat net heat exchange, their temperature will be adjusted until they have the same temperature. So that means two objects, when they have no net heat transfer between them, that means their temperature will be the same. Now, if their temperature are the same, that means these two objects, we say is that they are in thermal equilibrium. So all these pair of the concept, we can see is that they are connected by two-head arrows. Okay, so the implications is in two ways. Two objects are in thermal equilibrium means that they have the same temperature. If two objects are have the same temperature, that means they must be in thermal equilibrium. Okay, so if two objects are in their temperature are the same, that means that between them there is no net heat transfer. If there is no net heat transfer between them, that means these two objects must be in thermal equilibrium. So this diagram is clearly shows the relationship between the three concepts which can be learned from this example. So from my explanations, then it is clear that the quantity which is the same for two objects in thermal equilibrium should be the temperature. So the answer is C.